I'm Luke. Today on Out of Darts, I am going to show you something that Tarik has been working on for a while, a completely 3D printed, collapsible, arm-mounted shield. This is sort of a buckler design which can be strapped on an arm. This project is not what I would really call a failed mod, but it is a project that after many, many hours of designing and prototyping, it turned out that it's sort of a little unfeasible to actually produce. So while this isn't a product we're going to sell, I just thought people would really enjoy taking a look at what Tarik has been working on here. So tell us a little bit more about how the design process for this shield started.
Yeah, so I always have a different design process for different ones. This one actually went with a cardboard design. I needed a cardboard printout, and I needed to figure out like how much space I have to work with, and then figure out how these mechanisms work, how they catch on each other. So when I tried this, I had these little tabs here, you can see them, and they just kept breaking off all the time. To look at some of these other ones with the gears.
And you literally started, your very first model was made out of cardboard.
Completely, yeah, and we have some B footage for that too, so. But yeah, so I started with the cardboard and I tried figuring out how to make these, and these were a little too big, just didn't work out. So I was like, okay, the problem is these tabs don't work, so how the heck do I do this? So I tried these other designs. So you can see this little one where instead of having tabs, it opens up like that. So I don't know how.
So it's got sort of a center column that with teeth that each tooth grabs the next ring.
And the problem with this is like, how does it open up, right? Like I figured out how to get it to log, but I didn't figure out how to open it up. So I was like, okay, maybe if I go with a different design, maybe if I make it thicker, so you can see it like that. Opens up like this. You want to try playing with that and see how that looks?
Oh, that's cool. So each piece is basically identical, but catches on the previous part. And this is pretty close to how the final works. This is just a miniaturized version of that.
And yeah, usually when I do prototyping like this, I always go small because to speed up the printing process. And then I want to see if it's realistic. Can this do it through a 360? So how many would it take to do a 360? And then like I use nails and stuff like that, anywhere you can find to make that item. And the idea is to be a replicate. And then, I went a little bit bigger size, seeing if how big can I get. And then so when I finally settled onto these set of plates. And yeah, so what you can see with these plates is I was trying to figure out what kind of sizing can fit on the printer, because we use Prusa's, that's all the prototyping we do. So we were doing different scales, and then I started going bigger and bigger, and this is like bad filament. I always tend to use bad filament when I'm trying to prototype, so I can get some use out of it.
This one has like no infill. That's actually a really great tip. If you're just trying to figure out a dimension or size, you can throw the infill down to like 5%. Is that about what this is?
It's like practical.
Like I can, because this isn't production, I can like crush this piece of support.
As fast as possible, right? So
yeah, you're just trying to get a quick prototype out.
And then we got longer and longer, so this is the maximum a Prusa M3 can fit on this board. And then that kind of dictated how I'm going to make everything. Yeah, and you can see I was trying to curve, so these first prototypes, the curves was not that much relative to this one. So it's like, what feels good shape? And this is the problem with this kind of stuff, and what makes it difficult is like my arm is going to be quite different than a child's arm or your arm.
A little longer than mine, I think.
Yeah, so this like fits on my arm nicely, but other people might like come out, and you never know when it comes to this kind of design. And then when we finally hit up this design, we can actually crack this open. You can see how the inside works. I was utilizing that space. So what you can't really see very easily. Well, we need to unplug the battery.
Oh, to allow the gear motor to be manually.
So
is it low enough gearing you can push it open?
Yeah. So as we flip it, you can see that there's actually two switches here, and these are motor braking in essence. When these switches get hit, they'll stop it from both directions. And I got this idea actually from a completely different background. Somebody was trying to make a milling machine that would stop working when it reached a certain pit, so you don't go too far in. And he gave me this idea, and the cool thing is this circuitry is just a DT, a double pull, double throttle.
So the way that's working is you've got two pulls on the switches, so it can be on, off in either position. So when these are activated, when they're closed, the switch can be activated. When they're open, this switch can be activated, and it will just electromechanically, without having any board or controller. I didn't even realize until he was working on this project and sharing this with me, I didn't realize you could actually do that. And then I was looking at the wiring diagram and realized, of course, that makes a lot of sense. I can't think of a lot of normal applications where we would see that, but I imagine they must exist. If you know of any DP, dual pull, dual throw applications that are used commonly, I'd love to hear that. It's kind of a different type of switch and a different use compared to what we normally do in Nerf.
Yeah, like when do you need to switch polarity, right? Like that's that's what this does, right?
Fairly uncommon in our hobby at least, but it's a really innovative way to do it, because I would have probably thought that I needed to add logic or a control board of some sort to this to actually get it working.
Right, and then that's this big deal. Usually we don't care about sizing, but when you already have these blades that are going to take up a lot of your space, you can't have the hardware take up your space. So if I had to put a Arduino here, this is why it uses a 9-volt. I don't know if that was obvious, but we're using 9-volt and not like a LiPo like we normally put on everything. It's just because that took less space.
Yeah.
And you know, you want to know the speed for that. And this is just a gear motor. We didn't talk about it, but it's the same gear motor that we use in the Jupiter and everything else. These things are amazing. And they have multiple purposes.
The little N20 gear motors. Yeah. Yep.
And then everything is nails. So I always work with nails first, and then I figure out a different solution, something more feasible.
Nails are just great because you've usually got a lot of them lying around. The tolerances are pretty easy to figure out quickly, and then you're not wasting time designing in screw bosses and recesses and things like that when you might not even use that as your final design.
Right. And you can't 3D print this kind of stuff. Shafts don't really work as 3D printing, so you always have to figure out a solution. Gears, on the other hand, can be 3D printed, and they seem to wear out. They seem to handle pretty well. They don't wear out easily. I was surprised. I thought that this under stress would be too much, but not really.
I suppose it's a fair, not a crazy amount of torque coming out of that motor. What was the RPM on this motor? Do you remember?
I think it's the 600 one.
It's the 600. Interesting. Yeah. So he's got inside here. What is the type of gear called?
Worm gear.
It's a beveled.
Oh no, this is not
This is
worm.
a bevel. It's a. What is that? That's a bevel gear.
Right. It's a 90-degree turn.
So inside here, he's got a 90-degree. I think it's called a bevel gear, where the parts sort of mash up together like this. That way, it can change the direction for the orientation of where that gear motor needs to sit. I think this project is just fascinating. Obviously, I was disappointed we couldn't make this into a sellable product, but realistically, the complexity of this, the size, the amount of printing involved, and then even just reliability of a 3D printed part and small gear motor, it's just a really tough thing to put together, but it's such an awesome proof of concept.
Yeah.
So I really wanted to share this with everybody, even though it's not something we're going to sell in the shop. I don't like to call this one a failed mod because I think it's such a perfect proof of concept, but I would love to hear your thoughts on this. I mean, it would just be really sweet to have this on your wrist as like a buckler where you just hit a trigger and you've got your shield. I think that's just, it would be really amazing for play, but really challenging to actually implement and produce as an actual 3D printed item anyway.
Yeah, I mean, what I really want to design, if I go back to it, is these switches are so temperamental, as you know from it. It's like so easy for it not to click, and these blades are a little too small. I was thinking maybe I can do a full 360 design, and we can get a blade, because if you get a blade from here to here, then you can get these nice little full
So that would be considerably larger, more like, we haven't completed a 360 here, but more like this, where it would swing all the way around and complete the circle. That's very, very cool.
And maybe that's more doable. I don't know. It's something I would love to get back to it, but it's one of those pet projects that I can't give up on trying to get this to work.
I love sharing these projects with you all because both Tarik and I work on a ton of projects you never see. For every mod and project that ends up on the shop or ends up in a video, there are just so many failed ones. Whether they're failed ones or projects that we just couldn't polish or finish up, it really, you can do so much in that first 50% of the effort. I mean, I think there's a common saying, it's like 90% of the effort is that final 10% finishing work.
Yeah.
And so you come up with all these great concepts and we don't always get to share them. So I'm trying to make the channel also an avenue and a venue to showcase things like this. So do hit that like and subscribe button. If you enjoyed this, I'd love to hear your thoughts on it. How would you use this in combat if it actually worked? And would you wear something this size, knowing the bulk that is involved in order to have an expandable shield?
On-demand expandable shield.
On-demand expandable shield.
Yeah.
Might need some special rules in the game for this.
So that's hecka cheating, right?
Yeah.
Does it count when it's collapsed or when it's not collapsed?
I think it has to be expanded, right?
Yeah, that's what makes it interesting. And it would be so cool is, the dart comes at you and you're like, ah!
And it's really quick to open and close. Let's actuate that a few more times. So as you can see, when we're activating it there, we're just hitting it with a screwdriver. There's actually a switch in there, but do you want to tell them about how the actual intended use of it is?
Yeah, so I don't have my string, but it's actually a string that pulls through here and then follows back. Because the idea is that you would have it here, and then you would string actuate. So as your hand pulls in, it would open, and as your hand closes back, it will close. So the idea is that you pull, close.
I love it.
And And so it'd be quickly block, and then you can go back into playing. And anytime you need to pull up a shield, you would be able to do it.
Yeah, that's just awesome. Maybe there'll be a future someday with this, but I think it's probably not in 3D printing, more than likely, just due to the size of everything and the cost.
And blades, we don't know what would happen if somebody opens a blade and you open it like near ground, or you hit yourself with
Or
a
you
blade.
smash it against a wall. I mean, anything we produce, of course, has to be somewhat durable to be able to withstand the rigors of play. Thank you so much for watching. I hope you enjoyed this look at Tarik's fully 3D printed expandable shield. I love showing projects like this. If you want to see more of this kind of thing where it's not a finished project, do leave us a comment down below and hit that like button. It really does do a lot to grow the hobby, my channel, and the shop. Until next time, I'm out of darts.